What's up, guys, and welcome back to another I Be StuDYIN video. Today we're back at it with another math video, but this one's aimed at the IB Math AAHL students. One topic that is frequently assessed by the IB is vectors, and questions involving them tend to be rather convoluted. So today I will be going over one type of commonly asked vector question, which is finding the shortest distance between two lines or between a point and a line. Specifically, we'll take a look at two revision village questions. One about the shortest distance between a point and a line, and the other about the shortest distance between two lines. And without further ado, let's begin.
All right, let's start off with question number 36. We have a line with the equation r equals the vector 4, -1, 0, plus t times the vector 1, 1, and -1. We're told that point A has coordinates 4, 8, and -3, and that point B lies on L, such as the vector AB is perpendicular to L. So in order to understand what that means, let's draw a diagram first. Here is line L. Point B lies on line L. And the vector AB is perpendicular to L. So there must be a 90-degree here. All right. Firstly, we're asked to find the vector OB. Now, OB is the vector from the origin to point B. Since we know that point B lies on line L, we can use the equation for R in order to find OB. Now, this parameter t will determine where on the line L we are. We need to find the value of t where the point on the line forms a vector with point A that is perpendicular to line L. So let's combine OB into one vector by multiplying the parameter t to the direction vector on the right. Right, now since we know that line L is perpendicular to vector AB, I suggest that we determine what vector AB is. Now, whenever we have a vector like AB, we can decompose it into the difference of two different vectors, which is the vector OB minus vector OA. We know what vector OB is. We found that in the previous step. And vector OA can be found using the coordinates of point A that we were given in the problem, which is 4, 8, and -3. Now let's combine that into one vector by subtracting t, -9 plus t, and 3 minus t. Right. Once again, we know that vector AB is perpendicular to line L. Therefore, the dot product of vector AB and the direction vector of line L, which is 1, 1, and -1, must be equal to 0. Now, in order to find the dot product, just add the products of the x components, y components, and z components. So t times 1 plus -9 plus t times 1 and plus quantity negative plus quantity 3 minus t times -1 equals 0. Now let's simplify. Add like terms and solve for t. T equals 4. Now, in order to find vector OB, we need to substitute our newly found value for t, which is 4, into the vector equation that we had in the first step. So 4 plus 4 and -1 plus 4 and -4. And thus our answer for vector OB is 8, 3, and -4. Right. Now, for part B, we are asked to find the shortest distance from A to L. Now, the shortest distance that point A can be from L is if vector AB is perpendicular to line L. Therefore, we can just find the magnitude of vector AB, and that will give us the shortest distance. Since we have an equation for vector AB, we can just plug in our new parameter that we found in the previous part, which was 4. That leaves us with 4, -5, -1. Now to find the magnitude, or that is the length of the vector, you take the square root of the sum of the squares of each individual components. That leaves us with a length or distance of square root of 42 units. And that is our shortest distance. Right. Finally, we are asked in part C to find the coordinates of the reflection of the point A in line L. So if we draw another diagram, here's line L, point A, point B, and the reflection of point A across line L, which we will call A prime. We are asked to find its coordinates. So another way to write the coordinates of A prime is just by writing it as a vector O to A prime. And using the principles of vector addition, we can deduce that the vector O A prime is equal to OB plus vector B A prime. Now B to A prime is basically the same as vector AB. So we can replace B to A prime with AB. And since we have both of these vectors, we can just substitute them to find the coordinate of A prime. If we know that OB is 8, 3, and -4, and AB is 4, -5, and -1. Adding these vectors together, we get the vector 12, -2, and -5, which gives us our coordinates for the reflection of point A across line L, which are 12, -2, and -5. All right, that's question number 36. Let's move on to question number 37. All right, now we have question number 37, and it tells us that two tankers, A and B, are observed from an origin O. Their position vectors at time t hours after 6 p.m. are given by the following equations: RA and RB. We are asked to find the time when the distance between the two tankers is at a minimum. All right, so basically we need to solve for t. Now, in order to find the distance between the tankers, it would be wise to express the position of the tankers as vectors OA and vectors OB. Now we take our equations for RA and RB that we were given, multiply the parameter t by the direction vector and combine vector OA into one vector. And we do the same for vector OB. Right, now we need to find the distance between A and B, and we can do that by subtracting vector OB from vector OA, which will leave us with vector AB. All right, we are given the vector which expresses the distance between A and B, which is 5 minus 2t and 8 minus t. Now, again, to find the distance, we take the magnitude of vector AB, which is the square root of the sum of the squares of each individual component. So we're given the distance and we want to find t. Therefore, let's graph using the GDC graphing calculator the magnitude of vector AB. If you do it on your calculator, you are given this curve. And since we want to find the time when the distance between two tankers is at a minimum, we use our GDC to find the minimum x value, which is 3.60. And that corresponds to the time at which the distance between the tankers is at a minimum, which is 3.60 seconds. All right, we have successfully solved question number 37. I hope this video was helpful to you. If you are in AAHL, make sure to continue studying for our upcoming vectors test on the 26th of February. All right, that's all for today. Thanks for watching.